This video is going to cover percent ionization, and I'm going to use an example problem to introduce this topic. So calculate the percent of H3PO4 molecules ionized in a 0.10 molar H3PO4 solution. So we need to take the concentration of ionized molecules divided by the original concentration and multiply that by 100%. So if we were to come up with a formula for a percentage of molecules that are ionized, or the percent ionization, it's going to be the H plus concentration at equilibrium divided by the the HA concentration initial. Then we multiply this by 100% to get our percentage. So if we were going to calculate this, we need to write the equilibrium expression that dictates the reaction for H3PO4. H3PO4 is going to be in equilibrium with H plus H2PO4 minus in aqueous solution. The Ka1 for this is going to be 7.5 times 10 to the minus 3. And remember, if we have a polyprotic acid, the concentrations of everything are going to be dictated by Ka1 since it's much larger than Ka2 and Ka3. So we don't need to go into any in-depth calculations with H2PO4 and HPO4. So we can just set up an ice table with this particular reaction. Initially we have 0.10 molar for our H3PO4, and we have 0 for both the H plus and the H2PO4 minus. Our change in concentration is going to be minus X plus X and plus X, since we have a 1:1:1 mole ratio. And that's going to give us an equilibrium concentration of 0.10 minus X, X, and X. Okay? We're going to need to find the equilibrium concentration of H plus, so X is what we want to be solving for. So our Ka is going to be our concentration of X times our concentration of X divided by 0.10 minus X, which will equal 7.5 times 10 to the minus 3. Unfortunately, since this is small, we're not going to be able to use any approximations. So we're going to have X squared is going to be equal to 7.5 times 10 to the minus 3 times 0.10 minus X. Okay? If we rearrange this equation here, that's going to give us X squared plus 7.5 times 10 to the minus 3x minus 7.5 times 10 to the minus 4 is going to equal 0, and our x is going to equal 0.024, which equals the concentration of H plus at equilibrium, okay, because that's what we defined x to be up here in this ice table. Okay, now we're going to plug this in for the percent ionization equation, which is the concentration of H plus at equilibrium divided by our HA initial concentration, which is going to equal 0.024 divided by our initial concentration, which was 0.10. We'll multiply this times 100%. And we find that our percent ionization is going to equal 24%. And what we will find in here is that the larger the Ka, the larger the percent ionization. So we can use the same technique that we've been doing to find out equilibrium concentrations. And in this instance, we need an equilibrium concentration of H plus. Divide that by the initial concentration of the acid, multiply by 100%, and that will give you the percent ionization. And we also know that the larger the Ka, the larger the percent ionization.